So we'll start chapter 3. So which is closed loop. Closed loop control and study. So here we are talking about feedback control. What is a feedback control? So here we are talking about feedback control. So can you hear my voice? Can everybody hear my voice clearly? Okay. So what is a feedback control? Feedback control means taking control action after disturbance affects the process. So taking the control action after disturbance affects the process is called as the feedback control. Clear? So how does the systems look like for a feedback control? For a CSTR case, let's say this is my input. This is what is something going out with a control valve, or let's say you don't have any control valve. Then you have a jacketed for control. This is the example that we are following throughout the case. So this is water in, cooling water out. So cooling water. Then how does the feedback loops look like? So you are taking the measurement and you have a controller. You will give the set point. Accordingly, it opens the cooling water flow rate. So you understand how this is what is the objective here? What is the objective here is to maintain the CSTR temperature at the rate of 60 degrees centigrade is the objective. So you have a feed. This is product. This is A gives B. This is feed. This is product. This is A gives B. So cooling water in and cooling water is out. So this is the entire instrumentation part. Let's say you are measuring, going into the control loop and then taking the control action. So here there are different terminology. What is the objective? What you want to control? Here, let's say the temperature of CSTR. The temperature of CSTR is what you call it as control variable. And then cooling water flow rate. Cooling water flow rate is you are calling it as manipulated variable because you are manipulating this one. What is control variable is temperature of the CSTR. What is cooling water flow rate is manipulated variable. So what are the elements that you have? This is a measurement. This is the controller. This is what final valve is called as final control element. So what are the elements of a control loop is? This is a feedback control basically. Whatever you are studying is a feedback control. Feedback control. So temperature of the CSTR will become control variable. Cooling water will become manipulated variable. And then you have measurement, and you have a controller, and you have a final control element. So these are the elements of a control loop. Temperature of the CSTR is what is our control variable. It is not an input. Now, final control element is the cooling water flow rate, because that is the one which is finally controlling. How does this system works? Or let's say, how this control loop works. Let's assume that my field temperature is 60 degrees centigrade. So imagine the sequence of events. Here the temperature starts to rise. Why this is rising? Because there is some disturbance. So this is where the measurement, this is measurement detected 61. So measurement is measured 61. So after measurement, immediately the temperature doesn't come down. No? So measurement after, so signal has reached. By this is signal reached, let's say controller. Signal reached the controller. Then this is where, let's say controller, what it will do when the temperature increases, what does the actions? So now you go here and then see the sequence of events. First it detects the temperature, signal will reach the controller, controller compares with the set point, then accordingly it takes the control action. So this is in the controller is sitting in the DCS room. So in the plant you have, let's say, plant sits one side, control room is sits other side. At a different place. So there are a lot of cables coming from the plant to the DCS room, which brings the signals from the plant. Let's say what is the temperature of the reactor, what is the pressure of the reactor, what is the flow rate of the reactor. There will be so many signal coming into the plant. Then the controllers will take the control action, and then controllers will send a signal back to the plants. That is why all these DCS channels that you call in the plant will have a input output count. So some DCS panels are called as, let's say, 1000 input, 1000 output. That means you can connect 1000 inputs into the plant, 1000 outputs you can take out of the plant. So what is that inputs is nothing but the control signals which are coming from the plant. So you are taking lot of information from the plant. Accordingly, you are operating. How does an operator operates the plant? So then that means he needs to know the temperature, pressure, let's say flow rate, etc. Clear. So for that one, lot of signals are coming from the plant to the DCS room. Then accordingly, the controller will take the control action and then sending back to the system. So now, so this is where actually first measurement detected 61, signal reached controller, then controller increased cooling water flow rate. That is how it decreases the temperature back to 60 degrees. So because of the controller, what happens is even if the temperature rises, then the temperature will back to the 60 degrees by opening the cooling water flow rate. So the controller opens the cooling water flow. Controller opens means what happens immediately? Controller will send a signal to the control valve. Control will send a signal to the control valve. So that control valve will open according to the signal. Clear? Now, suppose if I want to operate, if I want to operate at the rate of 70 degrees, then what happens is you simply change the set point to 70 degrees centigrade. You simply change the set point to 70 degrees centigrade. Then the temperature, like which is at a steady state, or let's say suddenly 60 degrees, suddenly will go back and then settles at a 70 degrees. So if you want to operate the reactor at 70 degrees, then you change the set point. So then this is what is called as when the disturbance affects. When the disturbance affects, this is how the system. So because of some disturbance, the process variable has started to deviate and then controller has brought back to the 60 degrees because you have given a set point at 60 degrees. Suppose if my field signal is 60 and my set point is 60, then does controller takes any action? No. Controller will come into picture only when there is a disturbance. So this is what is called as regulator mode of the controller. Regulator mode, meaning that the system is responding to the disturbances. This is called as servo mode of the controller. That means if you change the set point, then this is servo mode of the controller. This is called as regulator mode of the controller. So clear. So controller basically comes into picture in two scenarios. One is if there is a disturbance come into picture. Second one is now everything is steady state. Now controller doesn't do anything. When the systems are in steady state, controller doesn't do anything. Suppose suddenly you go and change the set point intentionally, then also controller will come into action and make the control variable equal to the set point. So this is the two ways where the controller will come into picture. Just right up to this one. See, regulator mode means when the load changes or when there is a disturbance in the system, this is how the controller works. This is called as regulator mode. Suppose If my inlet temperature goes from 40 to, let's say, 50 degrees, then what happens? The outlet temperature will start to increase. But you have not changed the set point. That is why control will bring back the value back to 60 degrees. Servo mode means you are intentionally changing the set point. Now the controller is fine. So in what instances controller is active? When everything is working in steady state, controller doesn't become active. Controller is inactive. Suppose if there is a change in the disturbance, or if there is a disturbance, then my parameter changes. Then controller will come into action and will set the system back to previous steady state. That is one point where controller comes into picture. Second point is second point is suppose if you change this, now everything is working in steady state, but you have changed the set point, then also control will become active. That is called as servo mode of the controller. Now, next point is, so what is the dynamics of control loop? What is the dynamics of control loop? Meaning that, so let's say in regulator mode, as we said, this is how the controller is bringing back. The controller can bring back like this also, no? The controller can take, let's say, so this is 1, 2, 3. So here the system has disturbed here. Now it takes almost, let's say, 1 hour for the system to bring back to previous steady state. Here, let's say 30 minutes. Here, let's say 10 minutes. So in one case, the controller has brought the value back to the steady state in 1 hour. In second case, the controller brought the value back to 30 minutes. The controller. So what is the dynamics of the control loop? How does the control loop? So this is 1 hour is required if the systems are slow. 30 minutes is required if the systems are moderately slow. Suppose 10 minutes is something which is required for when the systems are very fast. Sometimes it may be 1 minute also. The controller immediately set back to previous steady state. Here it is extremely fast. Within 2 minutes, there is a disturbance, but controller has acted properly so that it has brought the system back to steady state in 2 minutes. But what is the dynamics? So what is the dynamics? So similarly in, let's say, servo mode, you have changed the set point from 60 to 70. So it can reach like this to 70. It can reach like this to 70, or it can immediately reach it to 70. Maybe this may be 2 minutes. This may be, let's say, 5 minutes. This may be, let's say, 15 minutes, or let's say 10 minutes. Or let's say this may be 20 minutes. So like this. So what is the dynamics of the control loop? So for dynamics of the control loop, so to study this one, we need to derive the transfer function. So we need to derive transfer function of control loop. So what is the dynamics of the controller? If you want to understand, you need to derive the transfer function of control loop. Now, this is the entire control loop. Can somebody put this, can you translate this entire information onto your control loop? How does the control loop look? Can you derive the transfer? Can you write the transfer function for this control loop? Or can you translate this entire information into, like, this is the closed loop control that we have written. What is the control diagram of this entire closed loop control? Can you transfer this entire CSTR with closed loop control into a control diagram? So what are the elements that you have in CSTR control? In the CSTR control, what are the elements that you have? So one is CSTR, second one is temperature measurement. What is third one? Controller. Fourth one is control valve. Now, so this, how do you try a control diagram? Let's say this is my CSTR. So what is input to the CSTR? Feed. Feed temperature is an input to CSTR. What is output of this process? Temperature of the CSTR. So you are measuring that CSTR. So that becomes input to temperature measurement is one element. So the temperature of the CSTR. Then you will have a signal coming out of the temperature measurement. This will go and you have a comparator here. So you have a temperature set point. So this is a plus minus. So the generated signal is the error. So how do you send, what is error is? What is error is? Set point minus measurement. So this error will go to controller. What does the controller do? Controller accordingly will give a signal to control valve. So the control valve will release the flow. So this both together will act on the system. So this controller plus and plus. So this is the control diagram of the CSTR. So this is a CSTR. What is input to the CSTR is feed temperature plus cooling water flow rates. These two are the ones which are affecting the temperature of the CSTR. So this becomes your disturbance. So what is the disturbance to the CSTR is feed temperature. So this is a disturbance and the cooling water flow rate. Both are acting on the CSTR. So the temperature of the CSTR is an output. The temperature is measured and it goes an input to the temperature measurement. Say the outlet signal is what is measurement, which is temperature measurement. Then you are generating the error. Suppose if error is equal to 0, that means controller should not do anything. Controller will just bypass the signal to the control valve. Clear? Control valve. Then if the error is, let's say, positive, that means your measured signal is 59, your set point is 60. Then error is positive. That means controller will have to decrease the cooling water flow rate. So accordingly, the control valve opens or closes. Clear? So this is the control diagram. This is called as closed loop control diagram. This is a closed loop control diagram. And this is called as feedback closed loop control. And this is negative feedback. Why this is negative feedback? Because you are generating the error as set point minus measurement. So there is positive feedback control loop also, but not in for chemical systems. Suppose if I put plus here, then your error will be keep on multiplying. Clear? So that is not in the, let's say, scope of chemical engineering. So negative feedback closed loop control system, this is called as. So what are the elements that you have? Process, measurement, controller, and final control elements. These are the elements. Negative closed loop control because you are generating error which is set point minus measurement. Positive feedback means set point plus measurement, which is not in the chemical engineering applications. See, the control valve opens the cooling water flow rate. That cooling water directly acts on the CSTR to affect this variable. So temperature of the CSTR is affected by feed temperature. Temperature of the CSTR is affected by cooling water flow rate, both. Why measured one is negative? Because you have to attenuate error now. So why I am generating error as set point minus measurement? Because error has to be generated like this. When error is equal to 0, it can indicate that the system is at steady state. Any doubts on this control loop? This is called as standard loop. This is standard control loop. Now what the next one is? So here, so we need to derive transfer function of control loop to understand the dynamics. So we need to derive the transfer function of control loop to understand the dynamics. So now if I write on a control diagram, then how does it look like? CSTR will have some transfer. CSTR will have some transfer function, which is GP, the process transfer function. So this is what is, let's say, load, which you will call it as load. Then you have a response, which is Y. So this Y response will go as measurement to M. So the measurement will have a signal compared with the set point R plus minus. Then you will generate the error. Then you will go to controller. Then it will go to GF. So GP is transfer function of the process. Every element in the control loop has some transfer function. But basically, what is transfer function? Transfer function is nothing but a dynamic model. So this is a load or a disturbance. This is transfer function, process transfer function. This is controller transfer function. This is valve transfer function. This is measurement transfer function. So every element on a control loop, or let's say, will become a transfer function, or let's say will become the entire. So this is CSTR. This is what is measurement. This is what is controller. This is what is final control element. Just understand the notation. I'll give 2 minutes time. See, what is GF, GP? These are all transfer functions. So transfer functions. CST, suppose if you are talking about a liquid level tank, then what is GP will become is R by AR S plus 1. If I am talking about a liquid level tank, this becomes R by AR S plus 1. Now the system, what is now the question is, what is the overall transfer function? What is the overall transfer function? So now you know the individual transfer functions. Now, when the systems are connected like this, what is the overall transfer function? Why do you need overall transfer function? What is the use of overall transfer function? What is the use of overall transfer function? If you derive overall transfer function, what do you do with the overall transfer function? So you can study the dynamics of the control loop. If you know the overall transfer function, you can study the dynamics of the control loop. So how do you derive the transfer function? So let's say overall GC GF GP GM by this is set point, this is load, this is the control loop. Understand? Now to derive the transfer function, that means overall transfer function y by u and y by r. This is what we need to derive. Y by u or y by r we need to derive. So what is y by u tells you is if there is a change in the load, then how does the system behaves is you will come to know from y by u. What is y by r tells you is if there is a change in the set point, it tells you what is the dynamics of y. So for that one, what I will do is I will assign some variable. Let's say a, b, c. This is d. This is y. So this is also y. This is c. So how many variables you have assigned? You have assigned a, b, c, d, e. So you have assigned 5 variables. Now you start writing the equations. What is the equation? What is transfer function? Output by input is equal to transfer function, correct? So you can write it as input into transfer function is equal to output. For example, A is the input to controller. A into GC equal to B. B into GF equal to C. C plus U equal to D. D into GP is equal to Y. Y into GM is equal to E. R minus E is equal to A. So these are the equations you can write. Is everybody? It is R minus E, this is minus symbol, this is plus symbol. See, measurement is also a process. You have a thermocouple, it has an input and it has an output. So if see, always there is some difference. Suppose if you take the thermometer, the actual temperature may be 25, but whatever the thermometer which may be showing is 24.99. So the actual, the suppose if I put the thermometer outside now, the environmental temperature will become a input. The mercury temperature will become an output. So every process has one input and one output. So here, so did everybody write these equations? All these equations? Then what is next step is eliminate all the variables A, B, C, D and E. Eliminate all these variables A, B, C, D and E. So how do you eliminate? Let's take this equation y equal to dgp. What is d? C plus u. What is c? bgf. What is b? agc. What is a? R minus c. What is e? ygm. So like this substitute. Clear? Maybe what I will do is, I will try to do here itself so that I can look at the equations. So what is y is dgp. What is d? C plus u into gp. What is c? bgf plus u into gp. What is b is plus u into gp. What is a? A is nothing but r minus c. So I am writing here y is equal to r minus c into gc gf plus u into gp. What is e here? ygm. So r minus ygm into gc gf plus u into gp, which is y. So this is what is the overall equation. So do it slowly. This is something which is slightly, but this is very simple. Don't take it as a very complex problems. These are very simple problems. So everybody done up to this now? So what is this equation? y equal to so let's copy this equation there. R minus ygm into gcgf plus R minus ygm into gcgf plus u into gp. Does this equation contains any of A, B, C, D, E? No. No. So, first case, suppose if U changes, that means what is this problem? Is it servo problem or regulator problem? U changes, that means load is changing. So your set point remains constant. Once set point is 0. So a set point constant means I kept the set point at 60. Then what is its deviation variable? 0, no? Then if I apply this equation, then what happens? Y equal to 0 minus ygm gcgf plus u into gp. Then what happens? What is y by u from this one? What is y by u equal to? Gp by 1 plus gm gcgf into gp. Y by I think there is some problem in the Zoom. I lost the entire thing. So basically, you have understood how to derive. Is everybody with me? I think there is some problem in the connection got lost. So everybody hears me? Okay. So that is how we derive the transfer function. Let's say, so if somebody has not noted down, then sorry for the inconvenience. But this is how sometimes technical errors comes. GP, GM plus minus plus plus Y U R. What is Y by U? GP by 1 plus GM GC GF GP. What is Y by R? GC GF GP by 1 plus GM GC GF GP. So what is the significance of plus and minus is? For chemical systems, it is negative feedback because the error generated is R minus M. This is called as negative feedback systems. But in electrical engineering, you will have the electrical engineers also will study this control, but they will study for positive feedback also. Now look at these transfer functions. Can you write any shortcut? Any shortcut if possible? Any shortcut? Suppose if you see y by u, when I am writing y by u, what are the transfer functions in between y by u? Gp only, no? Divided by 1 plus product of all the transfer functions. So what we can write is y by u r is product of transfer functions between y and u r divided by 1 plus or minus product of all transfer functions. This plus or minus. So what is the shortcut is when you are writing y by u, product of transfer function between y by u. So what you have only one transfer function divided by 1 plus. Why you are getting plus? Because this is minus. This is minus. You are getting plus because this is minus. Suppose if you are talking about positive feedback, then this becomes negative. So if this is, let's say, if this is plus, then you will end up having minus here. So what is the shortcut is product of transfer function between y to u and r, 1 plus or minus product of all the transfer functions is the shortcut. So I don't know. This Zoom. So hello, everybody is there? I think we have lost the connection 2 times. Can you hear me now? I think a lot of disturbances today. So basically that is a shortcut. So that is a shortcut. So which you can use it for, let's say, loops. So can we practice, let's say, so now I'll give, let's say, this is my control loop. So this is, let's say, my control loop, 1 by s, 1 by s plus 1. This is, let's say, u, this is r, this is plus minus y. Can you write what is y by u and what is y by r? So what is the answer? So now what is y by u is? What is transfer functions in between y and u, which is 1 by s plus 1 divided by product of all the transfer functions, 1 plus 1 by s into 1 by s plus 1. Why I have written plus here? Because this is minus. This minus will lead to plus here. Suppose this is plus, this is minus here. Now what is y by r? Y by r means what is transfer functions in between y by r, which are, let's say, 1 by s into 1 by s plus 1 divided by 1 plus 1 by s into 1 by s plus 1. So this is the y by r, this is y by u. So this is how you can use the shortcut in the problems. So is everybody clear here? So is everybody clear here? See, if you have a minus here, this is plus. If you have a plus here, this is minus here. That's it. Simple. Solving means this is the answer. This is the transfer function of y by u. This is the transfer function of y by r. See, what is y by u? For both y by r plus is applicable. Correct, correct. Because the denominator is same. Denominator doesn't change. Please observe. Denominator in both the cases doesn't change. Only numerator is what are the transfer functions which are in between y and u. What are the transfer functions which are in between y and r? That is the thing that you need to write on the numerator. See, what is the shortcut here is y by u. When you are writing y by u, what are the transfer function between y and u? Which is 1 by s plus 1. That will come on the numerator. Y by r. 1 by s into 1 by s plus 1. Denominator will be same. Denominator doesn't have any change. Yes, we will have a class tomorrow. Now, just solve this simple problem. Y and r. What is the transfer function here? So what is the transfer function here? No holiday for Diwali, no. So already we are running late. Here load is not there, only set point is there. So what is the transfer function? GP, y by r, GP by 1 plus GP. Clear? Now, can you write the transfer function for this loop? Y, r, plus this loop. If somebody says GP by 1 minus GP, you have done a complete mistake. First of all, is it a feedback loop? Is it a feedback loop? What is feedback loop? You should measure the output and that output should go as input to the system. So this is not a feedback loop because you are not measuring the output, no. So basically, no, this is not a feedback loop. So the shortcut will not applicable here. The shortcut will not applicable here. When there is no shortcut applicable, then what you should do is you assign the variables. So this is R. So this is also R. So this doesn't have any signal. So I put as A. Then how many equations you can write? When there is no shortcut, you have to follow original approach. Write the variables, write the equations, which is R into GP, which is equal to A. A plus R is equal to Y. Now if you substitute here, R into GP plus R is equal to Y. Then what is Y by R? 1 plus GP. This is something different. This is not a feed forward loop also. This is something different. So that is why you cannot apply the shortcut always. You have to be very careful. Now, can you write this problem? So what is Y by R? Tomorrow, do you come in the evening class because it is Diwali, no? So you need to celebrate crackers, etc. So I think I lost the. So I'll write the again. So otherwise, I can take in the morning session. Maybe you will have class of FM till 9 o'clock. So I can take from 9 to 10:30. So I can take 9 to 10:30. Or do you want in the evening only? It is your choice. So I got two. So I got 3 morning responses, 2 evening responses. Evening, morning, evening, morning. I think I got only entire response for the morning except 1 or 2. So we'll take tomorrow 9 to 10:30. Okay. Tomorrow will be 9 to 10:30. So somebody told a very good question. When we will have a breakfast if you take from 9 to 10:30? So you have to. So what do we do then? Can I give half an hour break at 9:30 to 11 for your breakfast? Okay. So we'll take 9:30 to 11. So only tomorrow 9:30 to 11, but day after tomorrow onwards 9:30 to 11 we will take tomorrow. So when you were 9:30 to 11 we'll take tomorrow. Maybe we'll have some little break also. Because till 9 you have FM class, no? Half an hour break, then 9:30 to 11. So what is the answer here? So to answer this question, first thing is this small loop you have to write the transfer function. What is the transfer function? GC, and this is GC1 by 1 plus GC1. This is y. This is the loop, plus minus. Then for this one, you know how to write y by r, which is GC, then G1. So GC into G1. So what is y by r? G1 GC divided by 1 plus G1 GC. Is it okay? This is how you derive the transfer function of the control loop. I think we'll stop here. So what we have learned today is the transfer function. How do you derive the transfer functions is what we have learned today. Clear? So we have learned how to derive. Tomorrow what we will do is some more complex loops. I will tell you how to derive the transfer function, and then we will go to another concept which is offset. So tomorrow 9:30 to 11 class. So we will close the class now and we are open for doubts. If you have any doubts, I can take your doubts. Repeatedly in the previous question where you was changing, you discussed y by u. Please repeat the ones. I am not understanding your question, Baba. You asked this question 10 times. Can you write it little clearly? For you, it is just copy paste. So interacting and non-interacting will come in the second chapter. Don't worry. When you connect two tanks in series, you can connect them in two ways, interacting and non. See, it is not feed forward. Feed forward is something different. Feed forward control loop, if you see, it will be different. Clear. So that is altogether has a different control loop, but that is some control loop, some different control loop. So I do not have the previous slides also because it is going in between. Between 2 points in the loop, we have two paths. So in the shortcut, how will you understand which loop? So here no paths, no. So here y/r, there is only, first thing is you remove this path. You translate this to a transfer function. Then you are writing y/r. Clear. So you can't write y/r before simplifying this one. So you will never have a two paths. Don't take it as, you will have always only one path. So why 2GC1? 2GC1 will not come, no? I have written this the entire transfer function as G1. Simple to simplify, I have written it as G1. That is why G1 GC by 1 plus G1 GC. So you can simplify later on, but I'm telling you the path forward. Y by UR will not be there. Y by UR will not be there. Either Y or Y by R. You will never have Y by UR. How to do with a variable? Which variable? How to do with variable? Variables you have to delete. See, variables are something which you have defined to derive the transfer function, because that is something which you don't know. That is why the process is you are assigning the variables and you are eliminating the variables. This is what you call it as cascade control. This is cascade control. This question is called as cascade control that you study in chapter 5. Y by R means servo mode, because you are talking about when the set point change, how the dynamics of control loop.